Alright guys, this is video 1.7. Today we're going to be talking about transformations and how they are made within a coordinate plane. Alright, transformations are going to be anytime you have a change in size, position, or shape of a figure. So let's say we have this triangle. Our triangle, our original, is going to be called a pre-image. The original is a pre-image. Most of the time, your vertices are going to be labeled. It may not necessarily be A, B, and C. It could be 1, 2, 3. When you are indicating that a transformation has taken place, you will use arrow notation. That's what this is called. You would just use a little arrow. And I'll show you how to write it up in a second. So then you get your new figure that's been transformed. And this one is called the image. So the original is a pre-image. The new one is the image. Now the way we label our vertices on here to show that they are related to the other one is this would be A with a little mark beside it, B and C. So if we were going to show that transformation had happened, we could say triangle ABC was transformed, using my arrow notation, to triangle ABC with our little tick mark up there at the top. So a reflection is one of the types of transformations. So this is the other way to remember this is like a flip. So reflection is going to be flipped over, an opposite. So think of the reflection of you in your mirror. When you're standing in front of the mirror and you raise your right hand to fix your hair, the mirror looks like it's their left hand because it is a flip, it is a reflection. So a reflection is always going to have a line of reflection. Now each point and its image are going to be the same distance from the line of reflection. So you've got to have your line there, and each point is going to be the same distance away. So just like if you're looking in the mirror, if you are close to the mirror, your image looks like it's close to the mirror. And if you're far away from the mirror, your image is far away from the mirror. So here we have a triangle. We have our line of reflection. We can say this is A, B, and C. Our image, now we might like to think that this would be A, but this is actually C right here, and this is A, and this is B. So that this distance and this distance are the same. This is the same distance from the line of reflection as that one. This is the same as this, right? Next would be a rotation. In a rotation, you're going to have a center of rotation, which is usually a point called P, and the image is going to rotate about that. Think of that as being like around the edge of a circle, just rotating. So if the chair in the middle of the room is the center of rotation and you rotate around that chair, you would be in the same distance from your center of rotation. So that it would still be the center. You're not going to change positions otherwise. So let's say we have this arrow and we have the point of rotation. So when we rotate our arrow around, it would be to right there, so that everything is still the same distance from our point as it was originally. Translation is the next one. Translation is called a slide. That's where the figure just moves. And all the points in the figure are going to move the same distance and the same direction. So you have this box, and the box moves. That means all the points move. So let's say that it moves right here. So this point corresponds to here. So let's label this A, B, C, and D. So this would be A, B, C, and D. Okay? So that each of them move the same distance. So that our B moves all the way up there and our D moves there. All right? All right, we're going to practice identifying some transformations. So what we're going to do is we're going to identify the transformation, and then we'll use arrow notation to describe the transformation. So we're going to start here. So is this a flip or reflection, a turn or rotation, a slide, or a translation? So remember, if it's a translation, everything has to move the same distance. So F looks like it's much farther away than the G's moved. In order for it to be a rotation, they're going to stay in the same order. So if this were to rotate, E would be on the bottom. So what this is a reflection. Here's our line of reflection here. So we can say that this is a reflection. Arrow notation says that triangle EFG is transformed into triangle E with a little mark, F and G. Make sure you have your little hash marks at the top. How about this one? So it can't be a reflection because if it were, this point right here would have to be the U for it to be a reflection, and it can't be. It's also not going to be a translation because it changes position other than just sliding over. So what this is a rotation, and it's actually, you can see that it is a 90-degree rotation. So we're going to call it a rotation. And we'll just say it's a 90 degrees. So we can say that, I'm sorry, not triangle. When it is a quadrilateral, meaning it has 4 sides, you can just label them. So RSTU is translated into RSTU. All right, so how do we draw and identify transformations on a coordinate plane, which is what the topic is for this section? So let's say a figure has the vertices at A, B, C. So we know it's a triangle. And after transformation, the image of the figure has vertices at the new A and the new B and the new C. So we're going to draw the pre-image and the image and then identify the transformation. So first we're going to have to label these 3 points on our axis. So at -1, 4 is here. That's A. B is at -1, 1. So here's B. And C is at 3, 1. So there's C. So here's our triangle. And our image is going to be at -1, -4. That's A. And our new B is at -1, -1. So that's here. And our C is at 3, -1, which is there. So here's our triangle, our image. So what type transformation? So if it were a rotation, then our C would be flipped over to this side, right? If it were a rotation. So it's not a rotation. It's not a slide because everything is in a slightly different order. If it was a slide, A would be on top. So what it is this is a reflection, and it's actually a reflection across the x-axis. So we would say that this is a reflection. So we can also, if what we know is we have the image and we are wanting to draw, the pre-image, and we are wanting to draw the image, if we know how much we're wanting to translate it by, it's pretty easy to do. So our vertices, first we need to find our vertices, our x and y's, then we can make the adjustment. So let's call this A, this one is A right here, B, and C. So if A is at -1, 1, we want to translate it. We want our new A. We're going to follow this instruction here. So for our x value, we're going to add 3 to it. So -1 plus 3 is going to be at 2. And our y value is going to be -4. So we have 1 minus 4, which is -3. So my new A is at 2, -3, which would be right here. Right, let's do B. B is at -3, 3. So my new B is going to be at my x, which is -3. -3 plus 3 is going to be at 0. And my y will be 3 minus 4, which is -1. So that's where my new B is. So I'm going to go to 0, -1. Here's my B. The point of C is at -4, 0. So I'm going to add 3 to my x value. So negative 4 plus 3 is negative 1. And 0 minus 4 would be negative 4. So I'll plot that. I'll go over to negative 1, down to negative 4. There's my C. So all this is a translation, so it's a slide. So my B moved this far, my A moved that far, and my C moved that far. All right, so that's how you do the translation. You just got to follow the instructions for how they want you to transform it to get your new coordinates. So when you come to class tomorrow, be able to draw a pre-image and an image if you have been given vertices, and then be able to identify a transformation of an image, and then find the coordinates of an image if you're given a pre-image, vertices, and transformation data, which would be the types of examples that I did in the video. So be able to do that when you come to class tomorrow, and have a great evening.